Ladies and gentlemen, I extend a warm welcome to you as we embark upon this profound voyage into the deepest enigmas of the cosmos and the very origins of our existence. Let us commence with a moment of absolute stillness, wherein we reverse the inexorable march of time to an epoch long past, an era preceding the advent of humanity, of life itself, or even of this cherished blue orb we call home. Our narrative unfolds approximately 4,600,000,000 years ago in an unremarkable recess of the Orion Arm within the Milky Way galaxy. Were one to gaze upon the expanse now occupied by our solar system, no orderly procession of 8 planets would meet the eye. Instead, a scene of primordial chaos would unfold, a vast nebula of gas and dust, the remnants of ancient stars, extinguished in the dawn of time, adrift in the piercing chill of the void. At the heart of this tumultuous cloud, a nascent celestial body kindles its inaugural glow, the protosun, a fledgling star amid a tempestuous birth, encircled by a rapidly whirling disk of matter. The fragments of dust, minuscule silicate grains, and drifting ice boulders orbiting this youthful star constitute the foundational building blocks of our world. In a lethal ballet governed by gravity and inertia, these particles collide relentlessly, merging, fracturing, and reforming in a violent and stochastic cycle of creation. As the mass of these aggregates swells, gravity asserts its dominion, drawing all inward and compressing the material until it forms incandescent spheres of molten rock. This marks the primordial form of Earth, an infernal realm with a seething surface of lava, an atmosphere laden with toxic vapors, and utterly devoid of life. Yet Earth's genesis transcends mere accretion. It is sculpted by cataclysmic cosmic upheavals. The giant impact hypothesis, first articulated by Reginald Daly of Harvard University in 1946, posits a seismic event shortly after Earth's initial coalescence. A hypothetical protoplanet, comparable in size to Mars and christened Theia, hurtled into the nascent Earth with an impact of inconceivable magnitude. This collision liquefied and ejected vast quantities of material from both bodies into space, forging a fiery ring encircling the parent planet. Under gravity's influence, these debris coalesced, cooled, and birthed our sole natural satellite, the Moon. Recent analyses from China's Chang'e 6 mission in 2025, which returned samples from the lunar far side, reveal isotopic signatures suggesting Theia originated from the inner solar system, akin to Earth, and that the impact profoundly altered the Moon's mantle, contributing to its asymmetry. Furthermore, emerging models propose that multiple impacts, rather than a singular event, may have played a role, aligning with observations of isotopic similarities between Earth and Moon rocks. The Earth-Moon system endures as a testament to this cosmic calamity, illustrating how order and vitality can emerge from devastation and disarray. Nevertheless, even with the Moon as companion, Earth remained a barren wasteland, an inhospitable grave incapable of nurturing life's spark. The true miracle resides in our planet's astronomical positioning. An improbable confluence placed Earth's orbit squarely within the habitable zone, often termed the Goldilocks Zone of the solar system, a narrow band where stellar radiation is neither so intense as to incinerate all to ash, akin to Venus, nor so feeble to consign the world to perpetual ice, like Mars. Recent research from 2025, utilizing NASA's James Webb Space Telescope, has refined our understanding of such zones, revealing that planets like TRAPPIST-1e, an Earth-sized world in its star's habitable zone, may harbor atmospheres conducive to liquid water, though uncertainties persist regarding hydrogen dominance or Venus-like runaway greenhouse effects. Courtesy of this ideal locus, as Earth's crust gradually cooled over millions of years, atmospheric water vapor condensed into millennia-spanning deluges, birthing expansive oceans. Water, the universal solvent and cradle of life, persisted in liquid form. This pivotal condition unlocked the portal for primordial microorganisms to arise, inaugurating an evolutionary odyssey spanning eons that culminated in humanity's presence today. A mere orbital deviation nearer or farther from the Sun would have precluded the chronicle of life from being inscribed. Surveying the remaining 7 planets in our solar system unveils the universe's harshness with stark clarity. Some are cauldrons of venomous gases, others colossal ice floes adrift in obscurity. This contrast renders Earth an emerald oasis, a precious gem forged by a cascade of improbable coincidences. Yet contemporary scientific rigor compels us to reassess notions of randomness and uniqueness. As humankind extended its gaze beyond the atmosphere, deploying advanced space telescopes to scan the Milky Way, a humbling revelation dawned. Amid the hundreds of billions of luminous stars, the probability of rocky planets, akin in size and placement to Earth, is substantial. By January 2026, NASA's Exoplanet Archive confirms over 6,000 such worlds, with estimates suggesting billions more. These potential second Earths may lurk in the radiance of distant stars, concealed by vast distances spanning thousands or millions of light years, rendering the verification of life an endeavor bordering on impossibility with extant technology. Within the Milky Way's grand tapestry, our Earth, with its rich history, cultures, and biosphere, appears as fragile and diminutive as a mote suspended in a sunbeam. This diminutiveness prompts a query of profound philosophical and scientific import. Precisely how vast is the universe, and is humanity's aspiration to conquer the stars a quixotic reverie? We oft hear of the cosmos's immensity, yet the human mind, attuned to terrestrial scales, struggles to grasp its true magnitude. Consider the Sun, the colossal entity in our system, voluminous enough to encompass over 1 million Earths, yet a mere dwarf yellow star, an anonymous grain amid the stellar desert. When one beholds the nocturnal firmament aglitter with stars, those twinkling points are not mere lanterns aloft, but gargantuan nuclear furnaces, separated by inconceivable gulfs. For instance, Vega resides 25 light-years distant, Altair 16 light-years, and Sirius, the night sky's brightest, 8.6 light-years away. To apprehend the despair inherent in such distances, one must redefine the light-year, not a temporal measure, but a spatial one, the span traversed by light, the swiftest entity in the cosmos, over a full year. At approximately 300,000 kilometers per second, light covers about 9,460,000,000,000,000 kilometers annually. This figure defies human intuition. For perspective, envision traversing this on a modern high-speed train at 350 kilometers per hour without pause. It would demand 3 million years. 3 million years suffice for ancient apes to evolve into modern humans, erect civilizations, and witness their fall manifold. An aeroplane at 1,000 kilometers per hour would require over 1 million years. Evidently, conventional locomotion renders interstellar travel utterly fanciful. Yet humanity persists in shattering barriers. In August 2018, the Parker Solar Probe was launched, a pinnacle of aerospace engineering, tasked with probing the sun's corona. Leveraging Venus's gravity for acceleration, it attained a staggering velocity of 690,000 kilometers per hour at perihelion, equivalent to 0.064% of light speed. This permits a journey from New York to Tokyo in under a minute. By 2025, updates confirm the probe's repeated record-breaking approaches, surviving temperatures exceeding 1,000 degrees Celsius while gathering unprecedented data on solar winds and magnetic fields. Nonetheless, even sustaining this velocity incessantly, traversing 1 light-year would consume 1,565 years, a span exceeding many nations' histories. Recall that Proxima Centauri, our nearest stellar neighbor, lies over 4 light-years distant. Thus, a one-way voyage to this proximate star would span more than 6,000 years with current pinnacle technology. Given humanity's ephemeral lifespan, the universe emerges not merely as vast, but as a prison of separation. However, the awe inspired by scale extends beyond. The figures heretofore discussed pertain solely to proximate stars in our galactic nook. As astronomers broaden their vista to the entire cosmos, they confront a numbing magnitude.
93 billion light-years, the diameter of the observable universe, the expanse whence light from celestial bodies has reached Earth since the Big Bang. To visualize, recollect Earth's antiquity of 4,600,000,000 years.
A hypothetical vessel at light's velocity would require 93 billion years to span this diameter, 20-fold Earth's age. Moreover, attaining light speed remains unattainable, for the universe is not static. Hubble's law and contemporary astronomical observations affirm the universe's ceaseless expansion, with acceleration over time. Distant galaxies recede from us, exceeding light speed. This engenders a harrowing philosophical corollary: realms of the universe forever beyond our grasp, irrespective of technological prowess or longevity. Light from those domains cannot surmount spatial dilation to reach us. We inhabit a luminous enclave, besieged by an eternally broadening eternal darkness. The actual cosmos may dwarf the observable 93 billion light-years, expanding each instant. Recent 2026 measurements of the Hubble constant, refined to approximately 73 kilometers per second per megaparsec via James Webb Space Telescope data, underscore this tension, suggesting potential revisions to our cosmological models. Thus, contextualizing Earth's formation, from chaotic gas cloud to verdant haven teeming with life, within this boundless, dilating expanse, evokes mingled pride and humility. Pride in life's tenacious flourishing through billions of years' vicissitudes, surmounting collisional cataclysms and climatic upheavals to forge human civilization. Yet humility in recognizing that our knowledge, our attainable realms, constitute a mere speck in an abyssal obscurity. Interstellar voyages or aspirations to colonize extrasolar worlds, while physically and biologically daunting now and perhaps perpetually, underscore our confinement by lifespan, light's velocity, and spatial expansion. Perhaps the authentic essence of cosmic exploration lies not in conquest, for the infinite eludes domination. It resides in comprehending our station. Earth's solitude amid cosmic vastness admonishes that this is our singular abode. The fortuitous alignments birthing us are inestimably precious. Rather than yearning for unreachable horizons, we ought to cherish the fragile vitality manifesting here, on this diminutive rock adrift in nothingness. For in the frigid, mute cosmos, Earth stands as the most resplendent miracle, the sole locus we may deem home. I thank you for devoting your time to this contemplative odyssey, until we convene anew for further tales of cosmic mysteries. Ladies and gentlemen, as the reverberations of the cosmos's imaginable expanse subside within our minds, we must traverse beyond the arid numerals of physics into the realm of more profound existential musings. The saga of the universe transcends mere dimensions or durations. Its essence lies in the dialectical interplay, rife with paradoxes, between humanity's finite perception and the infinite tapestry of space-time reality. Let us delve into an oft-overlooked facet when contemplating the nocturnal vault, the illusion of the present. When one beholds the gleam from a remote star, it is not the star's contemporaneous state that is perceived. Rather, it is a spectral missive dispatched from millions, nay billions of years prior. The observable universe constitutes an immense graveyard of light, wherein the vistas we discern may be vestiges of entities long extinct, detonated, or engulfed by black holes. We can never grasp the universe's now. Confined to Earth's localized present, all endeavors to commune or observe outward are dialogues misaligned with temporal phantoms. This imposes an absolute perceptual boundary. We are eternal latecomers to the cosmic banquet, confined to scrutinizing the remnants of predestined occurrences. Moreover, the universe's expansion, previously noted, transcends mere physical distension. It entails the gradual erasure of history. Envision a galactic civilization emerging eons hence, hundreds of billions of years distant. Accelerated dilation would propel all extraneous galaxies beyond their observational horizon at superluminal velocities.
Their celestial canopy would be void, an impenetrable obsidian solitude. Devoid of Big Bang evidence, cosmic microwave background radiation, or galactic web indications, they might erect flawed physical paradigms, deeming their galaxy the entirety of a static, eternal cosmos. This chills the soul. We inhabit cosmology's golden era, the singular juncture permitting sentient beings to perceive and comprehend the universe's authentic genesis. Our comprehension is not inevitable, but a temporal serendipity. Knowledge, in this vein, bears an expiry. The universe progressively seals its historical tome.
Confronting such impermanence, the Fermi paradox, where is everybody, assumes graver weight. In an ancient, expansive cosmos, intelligent life's emergence probability ought to be elevated. Yet, we encounter deafening silence. This quietude may not signify absence, but civilization's inherent fragility. Perhaps intellect begets a self-annihilative curse. Advanced societies, attaining technological zeniths, inexorably self-eradicate or retreat into introspective virtual realms, forsaking the barren physical cosmos. Or, more tragically, stellar chasms pose insurmountable biological and physical barriers, isolating each civilization eternally on its planetary isle, vociferating into the void, sans reply. Thus, cosmic silence mirrors not vacancy, but our profoundest dread, oblivion. From thermodynamics' vantage, the universe narrates a poignant saga of decay. The second law mandates entropy, disorder's metric, inexorably ascends temporally. This propels the universe toward thermal equilibrium, wherein energy disperses uniformly, precluding gradients for work, stellar genesis, or life sustenance. This is the heat death vista. Recent 2026 inquiries challenge whether entropy inexorably leads to such stasis in expanding universes, proposing that dynamic dark energy might sustain complexity indefinitely, though consensus favors eventual dissipation. Every radiant star beheld nightly, however majestic, is but a transient blaze exhausting finite fuel against perpetual gloom. We dwell in the universe's fleeting energetic interlude, a luminous flicker betwixt pre-Big Bang nihility and post-heat death void. This awareness eschews nihilism, underscoring order and life's supreme value. A complex edifice like the human brain, capable of cogitation, affection, creation, defies cosmic disarray's tide. We are order's torchbearers, albeit momentary in cosmic chronology. If conquest of the cosmos, halting dilation, or entropy reversal eludes us, what then is humanity's role? Are we utterly insignificant? Nay, our finitude and diminutiveness engender meaning. Immortality and boundless cosmos would render moments valueless, infinitely replicable. But our ephemerality, Earth's singularity, imbues each instant with profound ethical and philosophical gravitas. The physical universe may persist sans us, yet the meaningful cosmos demands us. Absent human, or analogous sentient, consciousness, the universe devolves to particles colliding in obscurity, bereft of beauty, ugliness, virtue, vice, or grandeur. We are the universe's senses, the medium whereby it contemplates itself. Through our gaze, it beholds nebulae splendor. Via our intellect, it deciphers its governing laws. We are not interlopers hurled into this realm, but intrinsic components, forged from stellar dust, awakened to discern our provenance.
This returns us to Earth, not as mundane locale, but life's sanctum. Dreams of Martian migration or extrasolar habitation, whilst romantic and technologically propulsive, must not obscure our stewardship of the maternal planet. Mars is a desolate wasteland, extrasolar worlds oft hellish cauldrons of poison or frost. Earth, with its tenuous atmosphere, azure oceans, and teeming ecosystems, embodies a probabilistic marvel, unreplicable. Ravaging this haven whilst fantasizing of void-born alternatives evinces arrogant folly. True civilizational advancement measures not spatial conquest, but profundity in comprehending and safeguarding extant life.
A superior civilization extracts not stellar energies, but coexists sustainably with its generative milieu. Ultimately, cosmic exploration constitutes spiritual cultivation. Gazing into yon abyssal darkness instills humility. Recognizing light's velocity barrier teaches patience. Confronting Earth's isolation fosters kin affection.
National frontiers, ideological schisms, petty resource squabbles appear ludicrous from orbit. Space reveals no terrestrial boundaries, merely a fragile sphere swathed in eggshell-thin atmosphere, adrift in hostile cosmic seas. That is our entirety, repository of beloved's repose, theater of all history, joys and sorrows. We, conscious stardust specks, stand at a pivotal crossroads. We may yield to avarice and myopia, or mature into life's custodians, guardians of consciousness's rare flame amid frigid cosmos. The response resides not in distant stars, but within each heart and mind. The universe shall persist dilating, stars birthing and perishing, yet existence's meaning inheres in cherishing this present instant, here upon this verdant jewel. Let cosmic awe transmute into life's preservation. Let our smallness catalyze unity. Let nocturnal silence remind that humanity's voice, laughter, melody, loving whispers, constitutes time's most precious resonance.
I thank you for devoting your time to this contemplative odyssey. Until we convene anew for further tales of cosmic mysteries.